Okay, here are your notes for 7-1, ratios and proportions. The first thing we're going to do is talk about the definition of a proportion, and that is a statement that two ratios are equivalent. A statement that two ratios are equal or equivalent. So just to define that a little bit more, what does that look like? Essentially what we're saying is we're taking two ratios. So two ratios, we're going to set them equal to each other. That might look like A is to B as C is to D. Each one of these is a ratio. This one is a ratio, and this one is a ratio. And we're going to talk about ratios in just a little bit, but first let's just talk about the proportion, which is two ratios set equal to each other, and then how to solve those. That's what we're going to do first. Before we move on to solving, let's discuss an extended proportion. That is three or more proportions set equal. That might be an example of something like 1/3 is equal to 2/6, which is equal to 3/9. Okay? So what we're saying here is that each one of these is equal to the same thing. And that's true. If I were to reduce the second fraction, 2 divided by 2 is 1. That leads me back here to my first one. And 6 divided by the same number, 2, is equal to 3. So 2/6 reduces to 1/3, and so does 3/9. 3 divided by 3 is 1, and 9 divided by 3 is 3. So these are three equivalent ratios. We call those extended proportions. All right, so proportions are two fractions set equal to each other. Now let's talk about how we're going to solve them. Cross multiply. Okay, so when you cross multiply, if these are your two ratios, you are going to, let me grab my color. You're going to do A times B is equal to B times C. So that's the equation you end up writing. That's how you cross multiply. Let's put that into practice using example A. So again, if I were to do x times 7, I'm going to write this one out. X times 7 equals, and then we're going to have 5 times 12 on the other side of the equation. We're always multiplying those two digits, and we always set them equal to each other. So we could obviously rewrite this so it looks more algebraic, so that it says 7x is equal to 5 times 12 gives us 60. And then to get x by itself, we divide both sides by 7. So x equals 8.6 for our first example. The second example presents us with a little bit of a challenge in that we are dealing with a binomial this time, y plus 3. So when we multiply, we need to be very careful that we are multiplying the 4 and the y plus 3. So that has to look like this. 4 times that total y plus 3 equals the 8 times the y. It is really, really important that you pay close attention to keeping that numerator, y plus 3, in a set of parentheses so that when we get ready to start simplifying, we are able to distribute the 4 to both items. 4 times y is 4y. 4 times 3 is 12. Okay, we have to continue doing some solving here, so we're using our Algebra 1 skills. We are going to combine our y terms all on one side of the equation. That gives me 12 equals 4y, and then I have to divide both sides by 4 in order to get y by itself. So 12 divided by 4 gives me 3 for y. Okay. In letter C, which I'm going to do over here where I have more space, we're going to do z times 20. So 20z equals 5 times 3, which is 15. So I just did this one out. I didn't actually write the steps like I have in the past. I just went straight to the multiplication. If you're comfortable skipping that first step where you're just simply writing it out, you can certainly start with 20 times z is 20z, and 5 times 3 gives you 15. We need to get z by itself, so we're going to divide both sides by 20. This does not divide out evenly. 15 divided by 20 is going to give you a decimal, 0.75. If you wanted to just reduce it, they're both divisible by 5. So 15 divided by 5 is 3, and 20 divided by 5 is 4. 3/4 is equivalent to 0.75. They're the same thing. So either answer will be sufficient. All right, D. Let's put it over here. 18 times n is 18n. And then I have 6 times n plus 6. So again, I have to use my parentheses so that I'm sure to distribute that 6 to everything in the set of parentheses. 18n equals 6n plus 36. I have to collect all my n terms on one side of the equation. 18 subtract 6 is 12. So 12n equals 36. Divide both sides by 12, and we get n equals 3. Okay? So that is solving proportions. We just simply cross-multiply. As I was saying at the very beginning of the lesson, each one of those fractions is considered a ratio. So let's now define ratio a little bit better. I'm going to clear the screen, and I'm going to scroll my paper up. Okay, so let's talk about ratios. So what is a ratio? Get my toolbar back. Okay, a ratio is a comparison of two values. Comparison of two values. So sometimes those values are written in a fraction. Sometimes they're written with a colon in between them. So it might look something like A is to B, and that's how you read that. The fraction part reads is to. So we say A is to B, or you could say it this way, or write it this way. A is to B. The colon still is to. A is to B, A is to B. You can write them either way. Most of the time we write them in the fractional form just because we're dealing with mathematics, and typically we are going to do some conversions and we need them to be in their fraction form to do that, okay? So we use comparisons to obviously compare two values, and a lot of times we're comparing things like two different lengths. In most cases we use these ratios to talk about blowing up a figure or reducing a figure. So think back to chapter 9 when we were dilating figures. We're going to use that same idea here. So this example is a photo that is 8 inches wide and 5 1/3 inches high is enlarged to a poster that is 2 feet wide and 1 1/3 feet high. So we're doing an enlargement. Before I do the problem, I always like to have a visual. And it doesn't have to be super duper accurate. It can just be, here's my photo. It's 8 inches wide and it's 5 1/3 inches high, and I'm enlarging it to a poster that is going to be 2 feet wide, and it's going to be 1 1/3 feet high. Okay, so there's my picture. What is the ratio of the width of the photo to, that's sort of like your colon, the width of the poster? So if we're thinking about this in fractional form, I want the width of the photo to the width of the poster. So this is always the first step that I do. Write my fraction out. What is it that I want compared to what other thing? I write it out in a fractional form. And then you're just going to replace width of the photo. What was the width of the photo? That was 8 inches. So I'm going to put my 8 inches in here. Okay, so the photo was 8 inches wide, and the poster was 2 feet wide. So I'm wondering right now how many of you are noticing that there's a problem with this comparison. The problem is that they are in totally different measurements. We can't compare apples to oranges. We have to be able to put them together and compare them in the same unit of measure. So you're either going to choose to change your inches to feet or your feet to inches. And so in my mind, I'm thinking that 1 foot is equal to 12 inches. So 2 feet is double that, or 24 inches. So I'm going to replace my 2 feet with 24 inches. And now I'm going to have 8 inches is to 24 inches. And then the only thing I have to do at this point is reduce if it's possible. And those two numbers are both divisible by 8. 8 goes into 8 once, and 8 goes into 24 3 times. So your ratio is 1 to 3. So that photo was enlarged 3 times its normal size. Okay, let's look at part B. What is the ratio of the height of the photo to the height of the poster? So I'm going to do that the same way. I want the height of the photo over the height of the poster. Same process, okay? The height of the photo is 5 1/3, and that is in inches. And the height of the poster is 1 1/3, but that's in feet. So unfortunately, we're going to have to deal with some fractions here. So the easiest thing to do at this point is to turn them into improper fractions. So remember that we do that. 3 times 5 is 15, plus 1 is 16. So I have 16 over 3 inches is 2. 3 times 1 is 3, plus 1 is 4. So I have 4/3 feet. I'm thinking to myself that when you make a comparison and you're dealing with both of these two smaller fractions that have 3 in the denominator, if I take and multiply my numerator by 3 and also my denominator by 3, because whatever you do to the numerator you have to do to the denominator, if I were to just multiply them both by 3, these cancel, and I just get 16 inches over 4 feet. Now again, the only thing I have to do is make sure that they have the same unit of measure. So 1 foot is 12 inches. So 4 feet is 4 times that. So 4 times 12 is 48 inches. So I'm going to replace 4 feet with 48 inches. So I get 16 inches over 48 inches. Both of those numbers are divisible by 16. 16 goes into 16 once, and 16 goes into 48 3 times. So this ratio happens to be 1/3 as well. Now, obviously we used the same example, and we compared the width to the height, and if the width was blown up by 1/3, unless the enlargement was not done to proportion, then the height would also have to be 1/3, or our poster would look really awkward and somewhat distorted. So typically when you enlarge something or reduce it, you have to have the same reduction and the same enlargement for both the width and the height. So it makes sense that these two end up being the same number. If they were not the same number, I would be a little concerned. That is your lesson for ratios and proportions.